All right, this video here is about solving exponential equations. All right, when we go to solve an exponential equation, first of all, we got to recognize it as that. If you see this, all it says is solve the equation right there. That's all it says right there, solve the equation. Well, you see, equation just means it's got an equal sign in it. Well, this is an exponential equation. We can identify that because we see that the exponent is where a variable is. So that makes it an exponential equation. All right, and it's saying that the left side is equal to the right side. So far, I haven't told you anything that you don't already know. But this b here, this variable, and this variable are the same. So we got to solve for it. All right, the way you do that is when you solve exponential equations, a lot of times you use logarithms because that is they are the inverse of exponentials, and we can use that to solve exponential equations. But if we recognize that, remember when we dealt with exponents, if the base is the same, that allows us to do a lot of things. All right, so what we're looking at here is that if we can recognize that both of these have the same base, we don't have to use the logarithms. So I can see that 16 and 32 look a lot alike. All right, but my base is not 16 and it's not 4, and I can tell it's not 4 because I can't multiply 4 times 16 and get 32. So my base is 2. Okay, 2 is a base of both of these. And the way I can get that is I can take this right here and write it as 1 over, all right, I'm going to go ahead and put this parentheses and put this b plus 3 right here. But what power of 2, with 2 as a base, do I raise this 2 to get 32? Well, 2 times 2 is 4, that's squared, times 2 is 8, that's 2 to the third, times 2 is 16, that's fourth, so it would be the fifth, so 2 to the fifth. All right, if you take 2 to the fifth, you'll get 32. All right, now on this other side, I want to write it as a base of 2, so that is 2 to the fourth power. This should be making some sense to you here. This right here is the power rule, and this right here is the power rule as well. But this still looks like a fraction, so I'm going to bring the reciprocal up, and I can rewrite this as 2 to the negative 5, like this, and b plus 3, and say that that's equal to 2 to the 4. I'm not changing this one at all yet. All right, I'm just moving this up to the numerator, which shows that I have 2 to the negative 5. This and this are the same. Now this is power rule and this is power rule. As you can see, they both are the same base, and that way I don't have to use logarithms. All right, so I'm going to use the power rule. I'm going to multiply this times that, like distributive property, and I get 2. Okay, I get 2 to the minus 5b minus 15 equals 2 to the minus 8b. It's just this times that and this times that, distributive property. Now, what I have here is I have now two exponents equal, two exponential here that are equal, the base is equal to each other, okay? And since the base is equal, that means I can just set the exponents equal to each other and solve. Anytime, if the base is equal, then these exponents must be equal. So what this gives me is minus 5b minus 15 equals this exponent, which is this right here. Okay? And we can only do this now without the logarithms when we can make the bases look alike. Okay? Make the bases be the same thing. If the bases are equal, then the exponents must be equal. All right? Then all we got to do is just solve for b. Now the best thing to do in this instance would be to go ahead and move this 5b here over here with this. And so that would be plus, let me scoot this up, I'm sorry. All right, that would be plus 5b plus 5b, and that would give us, this would mark out, and this is negative 15. And this over here would be negative 3b. That's just solving the equation, okay? All right. And then we divide both sides by negative 3. Negative 3. All right. And this cancels out because that's 1. And so we get b, let me scoot this up, b is equal to positive 5. b is equal to positive 5. All right, now of course we can take that value. That is our answer right there. Now we can take that value and plug it back into the original equation. All right, so let's do that, okay? All right, if we go over here and we have the original equation was 1 over 32 b plus 3 is equal to 16 to the negative 2 times b. All right, now we saw and said b was 5. All right, so what I'm going to do is I'm going to take and plug in the 5. I get 1 over 32 is equal to 5 plus 3 equals 16 is equal to negative 2 times 5. All right? Now, let's see what this does right here. This is saying this, simplify on the right, we got 16 to the negative 10. All right? And on this left side over here, we have 1 over 32 to the 8th. All right? Now, I know you're probably sitting here thinking that don't look nothing alike. But we can simplify. All right? Again, we can write these as bases to 2, right? All right? So this, again, would be 1 over 2, excuse me, 2 to the, let's correct that, 2 to the 5th, all right? And this would be 2 to the 4th, I still got to put this exponent over here, to the 8th, all right? And this would be 2 to the 4th times negative 10, all right? All right, let's see how this works, all right? I can rewrite this right here as 2 to the negative 5 times, what, 8? To the 8th power, rather. And this is the power rule over here as well. It's to the negative 10. Now, this should simplify without me having to mark it all, you know, to expand these, rather. I'm just going to say 2, I'm going to do the power rule. Negative 5 times 8 is negative 40. All right? And over here, I have 2. 4 times negative 10 is negative 40. So without even expanding those out to see what they're equal to, I can see that they are equal. So it does check, and so it's correct. So that's how you do exponential equations that do not have this, where you do not have to use the logs to solve for. You get to, you know, you're able to recognize that there's a common base. You take that common base and set both of them equal to each other, and therefore the exponents be equal, and solve for your variable.